Bismillahirrahmanirrahim. This is the second part of the concept mole. Now we will perform some chemical calculations that will help you to acquire some solid knowledge to solve future questions related to mole particles calculation or mole mass calculation. So let's get started. Now the outline for this video lesson is we will discuss about mole mass calculations. We will see some very important examples from your textbook, and we will also go through mole particle calculation, and you will find some important formula lists. Now let's get started. Mole mass calculation. So in this example we will be calculating the mass of 1 mole of a substance. We will calculate the mass of 1 mole of a substance. So here we have 3 elements: sodium, nitrogen and sucrose. We will count them. We will count, or we will calculate the mass of 1 mole of a substance. So for example, in case of sodium, we know that 23 is its atomic weight, so 1 mole of sodium will be equals to its relative atomic mass 23 gram. And nitrogen occurs as diatomic molecule. Remember that, diatomic molecule. We have already discussed the types of molecules in our previous video lesson. So diatomic means consists of 2 atoms, just like that in case of nitrogen. So we will multiply it with 2 because this subscript shows us the number of atoms that this molecule consists of. Nitrogen is a gas and it consists of 2 atoms, so it is a diatomic molecule. So when we will calculate its molar mass, so we will count it as 14 into 2, which is equal to 28 mu atomic mass unit, or 28 gram. So in third case, when we will calculate the molecular mass of sucrose, C12H22O11, 12, 22 and 11 shows the multiplication factors. So here we are, carbon has atomic weight of 12, so 12 into 12, and hydrogen has atomic weight 1 and it will be multiplied by 22 as shown in the subscript over here, and oxygen has 16 atomic weight and it will be multiplied with 11, which is subscripted over here. So it will make 144 plus 1 plus 22 plus 176. We have, for your solution, I have presented some video area. I have presented it over here. You can see this calculator mode and you will find the answer. It will become 342 grams. Let's see another example. Calculating the mass of given number of moles of a substance. So here we have 2 parts of our statement that will be shown in the question paper. So one part will provide us the general information, the next part will take us to the calculation part, that what we have to calculate. So let's state this. Oxygen is converted into ozone, O3, during thunderstorm. This is information for you. This is general information part. And calculate the mass of ozone if 9.05 moles of ozone is formed in a thunderstorm. So the key point here is that you have to know, you have to calculate, you have to find that 9.05 moles of ozone are how many grams of ozone. So let's go to the solution. We know that 1 mole of ozone will be equals to 16 into 3. 3 is subscripted over here, so we will multiply it with 3. 16 is atomic weight of oxygen, so it will become 48 gram. We will find that, so 9.05 moles of ozone will be equals to 48 gram plus 48 gram into 9.05, it will become 434.4 gram. You may see the calculation over here. Let's take another example, converting grams into moles. Sometimes you may be asked to convert grams into moles. So here we are with one example so that it may help you to go further. How many moles are present in a substance? A block of ice that weighs 100 gram. We will solve this. So for solution we have to know about 1 mole of water, which will be equal to 18 gram. We can say that 1 mole of water is 18 gram. So 18 gram of water will be equals to 1 mole. It is clear from here. So we will apply unit method, and if 1 gram of water is equal to 1 over 18, so 100 gram of water will be equals to 1 over 18 into 100 mole, which will be equals to 5.55 moles of water. You may see the calculation over here. Now I will help you to solve your self-assessment 1.9. It's part 2. I have solved it for you, for providing you a guideline to solve the rest of the parts. So I will state towards the statement of this question. So I will state the question statement. A spoon of salt NaCl contains 12 gram of this salt. Calculate the number of moles in it. So we have to find the number of moles. How do we find them? So first of all we have to calculate the molar mass of sodium chloride, which will be equals to 58.5 gram, and it will be equals to 1 mole. So 1 mole will be always equal to 58.5 gram of sodium chloride. If 1 gram of sodium chloride is 1 over 58.5, so 12.5 gram of sodium chloride, we are applying simply unit method, 1 over 58.5 into 12.5, so it will become 0.21 moles. You may see the calculation over here. So now let's talk about the mole particle calculation, calculating the number of atoms in a given mole. Now first of all let's go and check the statement of the question. A thin foil of aluminium is used as wrapper in food industries. This is a general information for you. Now the calculation part. How many atoms present in a foil that contains 0.2 moles of aluminium? So for solution we have to find first of all 1 mole of aluminium. It will always contain 6.022 into 10 raised to power 23 atoms, which we called usually Avogadro's number. So 0.25 moles of aluminum will contain, we simply multiply it with 0.2. So it will become 1.2044 into 10 raised to power 23 atoms. You may calculate it by yourself using a scientific calculator. So another example for you is calculating number of molecules in given moles of a substance. Now moles have been given and you have to calculate the number of molecules. So for this purpose we have to go through this example, and I will read this statement for you. Methane is a major component of natural gas. This is a general information. So how many molecules you are present in 0.5 moles of pure sample of methane? So 1 mole of methane contains, as we know, exactly 6.022 into 10 raised to power 23 molecules. So 0.5 moles of methane will contain, simply multiply it with 0.5, so it will get you to 3.011 into 10 raised to power 23 molecules. You can calculate it easily by using a scientific calculator. Now there is another interesting part for you, calculating the number of moles in the given number of atoms. Now atoms have been given and we have to calculate the moles. So how do we do it? We will do it in 2 steps. This is the step 1 in which we will find its molar mass. But before that, let me read the statement for you. Aspirin is a compound that contains carbon, hydrogen and oxygen. It is used as painkiller. This is the journal part of the questions statement. And an aspirin tablet contains 1.25 into 10 raised to power 30 molecules. How many moles of this compound are present in the tablet? So this is the calculation part. For this purpose, we have to follow this question in two steps. In step 1, we will calculate its molar mass of aspirin. You can do it simply. You have done it before, I hope so. From the previous video lessons, you have practiced it well, so you will be able to find that molar mass of aspirin will be equals to 180 gram. So let's proceed to next step. So same is the situation here. 6.022 into 10 to the power 23 molecules of aspirin will be equals to 1 mole. So 1 molecule will be equal to 1 into 6.022 into 10 to the power 23. So 1.25 into 10 to the power 30 molecules of aspirin will be equals to, simply multiplied with 1.25 into 10 to the power 30, and you will get approximately 0.2 into 10 to the power 7, and after further correction you will find that it will be equals to 2 into 10 to the power 6 mole. So these are very useful examples for you. Follow them, practice them, and you will be able to solve related questions. And I hope you have enjoyed this video lesson and follow the rest of the self-assessment questions related to mole particle calculation and molar mass calculation.